Okay, we are multiplying the 6x with this 2. So the first term was a 6x times 6x. That gave us 36x
It's six
squared.
x. Oh, okay.
So
Twelve
now,
x.
okay, good, thank you. So the 6x times the 2 is positive 12x. Carol, are you with us? Carol? No, Carol?
Yep,
Okay, good.
I'm
All
here.
right, good. All right, so the 36x squared was the first term. The outer term was the 6x times the 2. Now the inner term is the minus 2 times the 6x. What's that going to be, Carol?
Is it 4?
No, I'm multiplying this minus 2 with this 6x. What's that?
Negative 12x.
Carol? Is that negative 12x, Carol?
Yeah.
Are you sure, Carol?
Yes, sir.
Okay. So that's the inner term. And the last term, Carol, what is this? Multiplying those last
4. 4.
4. It's big. I need details, exact details.
Minus 4.
Thank you
Negative
very
4.
much. Minus 4. Thank you. And that's your last term. So the first term, 36x squared. The outer terms was positive 12x. Inner terms, negative 12x. Last term was negative 4. So this last line would be our final answer. That'll go in the box. So are there any like terms here that we can combine? Any like terms here?
Yes,
What's that, Stephanie?
the T12X's will cancel out.
They will cancel out. Perfect. One is negative, one is positive. They will cancel out. So that leaves you with 36x squared minus 4 as your final answer. Pretty good. Do we have a question on that particular problem? And
No,
I have just changed my mind.
go to the whiteboard.
Yep. I have just changed my mind. And can you want to see this?
At a
T49.
T.
Yes. T49DK.
T4.
T49DK. That's, I think we can
Let
do
me
a
go.
few of these. I've decided we can do this.
Let me get my other laptop there.
Okay, we're going to do the speed one. Nice. Thank you much. And for a few minutes, I see Carol. Thank you, Carol. Can we get a few
You're welcome.
others? Thank you, Freeman.
I'm waiting for my daughter to bring my other laptop.
All right. Did you write the code down, Taylor?
Yeah, I did.
Okay. Thank you, Stephanie. Where's Brian? Oh, that's you, Brian. Never mind. And Stephanie. Okay, cool. So the next problem we're going to try. Now I'm going to help you all get started with this. So here's example 2. I think we did one like this, but I'm going to find out really, really soon. Oh, you know what? I need to mention one thing. Let me rewrite this for a second. Let me rewrite example 1 for 1 second, because this will come in handy. If you look at example 1, You know, these two binomials are almost twins. You notice that? Did you see that?
Mm-hmm.
They're almost twins, except one has
There's
a
a
negative
different thing.
and one has a positive. That's the only difference. So they call these types of binomials conjugates. And you don't have to define it or anything, but what will happen is when you have conjugates and you multiply conjugates, the final answer will always have two terms because
The F and the L.
the F and the L, yes, because the terms in the middle and these in the middle, they will always cancel out. So you would just have the first term multiplied and really the last term because the middle terms will always cancel out when you have conjugates. And again, the conjugates are the two binomials are exactly the same except for the signs. One is positive, one is negative. So I just wanted to mention that little thing. And this will also come in handy when we factor, which will be next week. So we'll see something like this again next week also. So this is a what do they call that when you see something that's coming in the future? There's a name for that. I can't think of it right now. Anyway, example 2 is the following. All right, so this is 5x plus 3 squared. Now, did we cover anything like this last? Well, we'll find out in 1 second. So when you say binomial squared, do you know what I want you to write over here?
Yeah.
Okay, what's that,
The
Stephanie?
same 5x plus 3 and 5x plus 3.
Okay, yes. So when you see something squared, Taylor, you're gonna write the exact same polynomial twice. Now, I would like you to multiply this out using this first outer inner last. You're gonna get 4 terms here. And you can combine your like terms. You're gonna write your final answer here. And I would love to see at least the final answer on the whiteboard. And if you want to do the whole thing on the whiteboard, that's fine also. But let's try this right now and see what final answer we get. And you just do the best you can, Stephanie. Whenever you need to take a break or whatever, that's fine. 100% fine.
Okay.
I am.
Okay.
I think
Thanks.
I'm doing my best to record this, and you'll be able to see it later. Have anybody been able to watch any of these past videos? Just curious.
Yes.
I did.
Yeah,
Yes.
I did.
Okay. All right. Good enough. Thanks. So we're gonna wait. We're gonna give you all a few minutes to see if I get any whiteboard answers.
I have an answer.
Oh, you sure do. That was fast. That's nice. That is 100, Stephanie.
Thank you.
Okay, we got a 100. Let's get an okay. Bukelu is getting close. Except for that second term.
See my answer, Professor?
Was that Freeman?
Yes.
No, Freeman. Sorry, Freeman. Freeman, these are not conjugates. Conjugates, the signs are different.
Oh, okay, okay,
These are
okay.
exactly the
I see what I
same.
did wrong.
Not a conjugate.
Okay.
Conjugate.
Okay.
And I do believe Brian, nice job, Brian. Thank you very much. Bakelu looking good. I think Carol, that's perfect. Thank you, Carol. It's perfect, Carol.
Okay.
Oh, wait, hey, Carol, don't go any further. Just stop it right there.
Who, me?
Yes.
Okay.
That one line you got is perfect. Don't go any further. And okay, Bakelu, I think that's good. I'm waiting for Freeman to fix it now. Just give me 1 second for Freeman. Oh,
I'm done.
you got it, Freeman. Hey, everybody's got it.
Thank you.
Everybody's got it. No need to go over this one. I have 100% compliance. Love it. Love it. Very nice. Okay, we're just gonna do one more of those just to make sure that we have no confusions on that. We might even share a screen a little bit later, but first, before we share a screen, let's do one more multiplication. That's b minus 7. Let's do that one, please. It's similar. I just want to make sure that we are on point. And I didn't hear Taylor's answer. Did you get the answer in that last one, Taylor? I did not hear Taylor. Okay, let's see. Let's go. Okay, keep going, Stephanie.
Keep going.
Oh, okay. All right. Now I see the third line now. Okay, Stephanie, thank you. Oh, we're almost ready for division problem. Waiting for Freeman, Carol, Bakelu, Taylor's with us, and Brian. Let's get a few others here. I think Brian's trying to get back here. Come on, Bakelu, where are you? I don't see it. Bakelu?
I'm coming.
Oh, you know what? Hold on a second. Thank you, Brian. Carol, no. Come on, Carol. You did so well before. Oh, wait a minute. Oh, wait a minute. Let me back that up. Thank you, Freeman.
Welcome.
Very nice.
Let's try 3 monomials. So let's see this before we do. Oh, well, for those who have seen this, let's see. Yeah, this will be the next one. Stephanie.
What is it?
Negative 5xy to the 4th times negative 5y squared times 2, and that's a z. And You can start that while I look at our other whiteboards. Freeman's is perfect. Brian is perfect.
Thank you.
Bakelu is getting almost finished. What happened to Carol? Or maybe she's doing it again.
I erased it. I thought it was wrong.
It was wrong. I thought you were going to do it again, Carol.
No,
And I could do it again, Carol?
I don't think so, Professor.
Really?
I'm
All right.
speed. I might be wrong. I only
on.
want to try.
Serious? All right, Carol.
Yeah.
All right. I'm waiting for Taylor now. She's almost finished.
Professor, mine's. Oh, that's not finished. But can you go over it?
Yes. Are you finished?
I think so.
Well, I see 3 terms.
So are those 3 times right?
Yeah, but it's supposed to be 4.
All right. So all right, I know what the last term means. I'm about to put it on there.
All right. Well, let's go do this so Carol will be happy. So Carol, did you write? You did write the b minus 7 times b minus 7, right, Carol? Carol.
I'm right here.
So did you write the b minus 7 times b minus 7, Carol?
No.
Why not?
That-
It was just like this one, Carol.
That's why I went wrong.
Gotta follow the process.
Right. My fault. Yeah, you right. It was just like that.
It's just like it. Okay, so let's see who has this one. Let's go back to the whiteboard a minute. And
Last year.
Thank you.
Freeman, you're gonna try this one too, right?
Yes, I'm trying, Professor.
And Brian, yes. Bukela. Hey, Bukela, you didn't finish. You know that, don't you?
I finished, Professor.
You did?
Yeah.
Wait a minute. Now, Bukela, your final answer has how many terms?
This cancel out or no, Professor? I have a question. The 7B and the 7 weeks terms cancel out or no?
No, they do not.
Right. That's what I thought. That's why I didn't finish the thing. But all right, wait a minute.
All right. Okay. Let's go over this. Okay.
That's why I didn't finish it.
All right. So, Carol, you multiply those b times the b, Carol.
Hold on, Professor. Give me 1 second. I'm not feeling well. Give me 1 second.
Let me see. I think
No, back off.
that's very good, Stephanie. That's great. That's great job as well, Brian. That's great. That's great. Okay, you two just hold tight a second. 1 second. We still waiting on Carol, correct? And Bukelu, is that your final answer on your whiteboard? Bukelu?
Yes, Professor.
Okay, Bukelu. Okay, all right, hold on a second. Wait a second. All right, look.
I'm sorry.
You multiplied the first term, so that was b squared.
Yeah.
Then you multiplied the outer terms, so that was negative 7b.
Yeah.
Yes. Then you multiplied the inner terms. That was also negative 7b.
Yes.
And then the last terms you multiply is positive 49.
49. Oh, it comes positive.
Isn't that where you stop, Bukelu? Is that where you stop?
Yeah. Yes.
Oh, yeah, that's supposed to be positive, Bukelu.
No, yeah, I make negative. Yeah.
Now, you know we're not finished, Bukelu. That's 4 terms here, right?
Yes.
But 2
Oh. The 2 7Bs cancel out, right?
Is that true or false,
Yeah.
Bukelu?
No.
No.
Why don't they cancel out?
Because they're
Both,
not like
both
terms.
negative.
Both negative. So what does that become, Bakelu?
Maybe 0. I don't
No,
know. I
no.
don't know.
14B.
Say that again, Freeman.
Minus 14B.
Okay, good. I don't know if I heard the minus at first. Negative 7B, negative 7B, that's negative 14B.
Okay.
Later.
So this should be your final answer.
Here.
Okay, thank you.
Carol, you with us?
Yes.
All right.
I'm having problems with the next one, Professor. I'm not sure.
Okay, now Stephanie was a bingo and Brian was a bingo, and I'm gonna wait until Bakelo gets. Let's give Bakelo a minute. Whoops,
Okay.
I was about to hit the wrong button. I'm glad I didn't hit that one. Bakelo and Taylor and Carol.
All right, I'm going to try this one out, Professor. Ooh.
Give you a couple of minutes. We're in pretty good shape now. I am very happy with our progress. I'm giving Bakelu a few more minutes. I will do that. How about you, Taylor? You ready now?
No, I'm confused with this one, so go ahead.
All right. Let me double check with, I don't see anything with Carol. All right, Carol. So here we go. Here we go. Oh, okay, Bakelu.
I'm done. Professor is
All right.
right. No, I don't know.
Not exactly, but here we go. Let's do it right now. So first of all, that's -5. And that's, you do see this, do you see this a negative sign here? Can you all see that?
Yes. Yes.
Make sure that negative is easy to see. So negative and a negative and a positive. So our answer is going to be positive or negative, Freeman?
Positive.
Positive. Okay, great. Now,
For the first one, yes.
now look, that's one term, that's one term, that's one term. We are multiplying, multiplying, multiplying. So when we multiply monomials together, the answer is going to be one big monomial. It's going to be one big monomial. Because, okay, we will compare the difference in 1 second. So we're going to multiply the -5 and the -5.
Okay, because we're going to combine all the, okay.
So that's 25 times this 2. So first number we're going to write is 50.
50. Okay.
Okay. Now,
Professor,
yes, Brian.
I did it a little different. Never mind. It's cool though.
Like you multiply the first two together or something?
Yeah, I just did the first two, brought them
Yeah.
down, then I did the second.
Yeah, you can do that as well. Yes, sure can.
Yeah.
So either way will work. So now this X. There's no X here. There's no X here. Notice that? So I'm just going to bring it down. There's no other x's. Y, there's other y's. What should be the exponent of the y? Bekelu?
6.
6. Good, good, good. Because when we're multiplying, adding those exponents. What's next, Bekelu?
Is a plus.
Not what do you think, Freeman? What's next?
We make that 5 times 2 is 10. Minus 10.
No, I mean we multiplied these numbers together already.
The Z.
Bring down the Z. Just bring down the Z.
Bring down the Z. Yes, let's bring down the Z.
Oh.
So that's the answer to that one. So let's compare this to example 4. Look at example 4 for a second. Example 4, let's say, is this. So example 4, I have a monomial times a binomial. Do you see the difference between these two, Freeman? These are monomial,
yes.
monomial. So you can multiply all those together in one larger monomial. But this is a monomial times
You have to
binomial.
distribute. Yeah.
Yeah. So please write down what your answer would be for example 4. Let's try that. Because it's a little different when you have a monomial times a binomial as opposed to 3 monomials. Let's see if we okay with that one. Let's pause. Now look it on the whiteboard. Look it on the whiteboards. You still with us, Carol?
Just got back.
Thank you. Great.
Mm-hmm.
Oh, Bekelu, that is okay. Bekelu's got an answer. That was fast.
Oh no, it's the first it's example 3, Professor. It's not this one.
Oh, okay. Okay.
Yeah.
Oh, yeah. Right. Gotcha. Right.
Yeah.
Okay, keep going, Brian. You're almost there.
So you want me to, okay, so I keep going after that?
No, that's just, you can't go any further than that. Yeah, I think that's a wrap.
Oh, okay. All right.
Yep, it is. And let's see, does Stephanie I gotta make Stephanie's a little larger to see.
Not sure about this one.
Wait, what's up with the 3? Why's that 3 there, Stephanie? Oh, gotcha.
I added.
35. Never mind. Okay. You can't do that, Stephanie.
No?
No. I'll explain why. Un momento. I'm waiting for Bekelu.
I write it, Professor. Is it right?
So, Professor, do I stop right here?
You would, yes.
Oh, okay.
Okay, Bekelu
I did.
is. That's good, Bekelu. Yes.
Okay. Thank you.
Freeman, are you finished? Freeman,
Yes.
you finished.
Yes, but I guess it's not finished. I don't know what else to do.
All right, okay, all right. All right, let's see. Waiting for Taylor. Carol, are you gonna do this? No, maybe. Oh, I think you are trying to do it. Yes, you are. Wait, let's give Carol another minute.
That's not right then.
No, that's not right. Erase that 5.
Who, me?
Carol, is that Carol?
No, it was me, Stephanie.
It's definitely okay. No, I think what you got is fine. By crossing out that last line, what you got
Oh,
is okay. Carol, what's going on, Carol? Carol? All right. Let's proceed.
I didn't even know I was muted, Professor. I was talking. I didn't know I was muted.
Oh,
I was
you're
asking if I
muted.
was going in the
Yeah.
right direction. I'm sorry.
So you wonder if you're going in the right direction, correct? Yeah, yes.
Yeah.
I'm going to say yes, but you got to keep
Okay.
going. You got to keep going.
Okay. All right.
Okay, Freeman. So here's the deal.
What's
You,
going on?
you got to multiply these two together first. So
Did that?
you got to write the 25. So what would you write, Freeman?
You write down the X
Okay.
In the form.
and then the Y to the 6.
Okay. Yeah. Good. That's fine.
And then I put plus 10Z, but I guess that's not right.
It's 10. You need the X. That's here. You need the Y to the
Oh.
4th. That's here.
Oh,
And
sorry,
then-
Professor. I left
And
all
then,
that out.
and
Sorry.
then the Z.
Oh, okay. And I get it.
Now, since these are not like terms,
I'm always thinking
because
something else.
like terms have to have the same variables and the same exponents. They don't have that. So this is as far as you can go.
this.
Okay.
What do you mean, Professor, the same variable and the same exponent?
Okay.
Like the Y6 would have to be on both sides?
Yeah, the y's would have to have the same exponent. And if there's a z here,
Okay.
there's got to be a z here also. All the variables and the exponents have to be.
Okay.
I realized I was still muted.
So that's the last step right there.
Yes. You mute again if you just said something.
I see what I did wrong. Okay.
Nobody heard you, Carol, if you just said something else. So I guess you didn't say something else? Okay. Okay, Carol, didn't say anything else. Fine, cool. New topic. Hey, this is the last topic for this section. So that's awesome.
This is what I had trouble with on the homework.
Dividing polynomials. You would not have any troubles in about 10 minutes, Stephanie.
Okay.
Troubles are about over. So we're going to divide polynomials. Here's a good example right here of dividing polynomials. We got a trinomial in the numerator. And for this class, we just deal with monomials in the denominator. So we got trinomial divided by binomial. And here is the most pleasant.
Wait a minute, Professor. You said a trinomial divided by a binomial?
I'm sorry, I did say that.
Oh.
Monomial, thank you.
Oh, okay.
Monomial, thank you. Yes. Trinomial divided by monomial, thank you.
Trinomial divided by monomial.
So we're going to split this fraction up. That's how we want to do this. We're going to split the fraction up in the following way. So x to the 4th is the first term. I'm going to divide that by the monomial. Plus sign, plus sign. The x to the 3rd is the second term. I can divide that also by the same monomial. Plus sign, plus sign. Third term, 2x squared. And again, that can be divided by the same monomial. Split them all up by the same monomial.
Oh my goodness.
That's okay. Taylor, the first term numerator, second term numerator, third term numerator, and I put the same denominator under each of those numerators.
If you about to do what I think you're gonna do, so do we keep that same denominator?
We're going to try to simplify each one of these fractions separately.
Oh wow.
In other words, what's the coefficient in front of this x to the fourth? What's this?
One.
One. Very good. All right. So can we reduce 1/4? No.
No.
So we're going to leave the numbers just the way they are. Put the 4 here. And if you want to put the 1 there, you can, or I'm going to leave it off. But what can we do with these variables?
Subtract
Subtract the what?
the exponent.
Exponents.
The exponents. So 4 minus 3 is going to be the 1. And since the 4 is a higher number, this answer is going to go to the numerator. So this fraction reduces to x over
X over
4. Plus sign. Again, what's the coefficient of this x to the third?
1.
1. What can we do with these x's here?
Subtract, cancel out.
In fact, since they're both 3s, both to the third power, they cancel out. So what we have here is 1/4. And the last part, plus sign. What should I write? Someone?
1/2.
1/2.
Okay, so the 1/2 takes care of the numbers. This 2/4 becomes 1/2. But I'm not quite finished.
Would it be a negative? No. Would you have a negative exponent?
Well, let's avoid the negative exponent. Let's do this. We're going to subtract these exponents, right?
Yeah.
Right.
Now, since the larger exponent is in the denominator, let's put our
Gotta
answer.
flip it.
Just put your answer in the denominator.
Okay.
Oh.
And you don't have to even put the 1 there, really. So wherever,
Wait a minute.
yes.
Since it's in the denominator, you just gonna put it in the denominator?
Yeah, well, what we can do is we can take this 3 and subtract the 2. 3 minus 2 gives you the 1 still, but since the 3 is the larger number, it's in the denominator, that's where our final answer is going to be, in the denominator. And that avoids having to get the negative exponent, because the negative exponent has to go to the denominator anyway.
Anyway, yeah.
So you wouldn't have to write the reciprocal of nothing?
Well, let's just take a look at this one, for example. So if you have 2/4 x cubed x squared. So what you could do is you make this 1/2, and you can make this x to the -1. if you want to do that, okay? 2 minus 3 is minus 1,
Mhm.
but the x has that negative exponent. So you will leave the 1/2 alone, but this x to the minus 1 have to go into the denominator
Okay.
and become positive.
Right. Okay.
So
I see.
to avoid doing this, I'm saying wherever the largest exponent is, in this case, the denominator, then that's where your final
Yeah.
answer is going to be.
Right. When I did it on the homework, and you know the review button on the side, it takes you to that step right there.
Right
That
here.
last. Yes.
Okay. And that's perfectly fine. But if you wanted to avoid these extra steps, if you just go wherever the highest exponent is and put your answer there, that avoids that piece.
Good.
So this would be your answer right here. So Taylor, that was okay, right? You think? Cool. Freeman, you have a question on this?
No.
Bakelu?
No problem.
Okay. Brian's happy with that?
I'm happy
Yeah.
with it because you said it's the answer, but I have a question.
Yeah, sure, of course. Yeah. Right. Please. Yes.
So X, the X over the 4, the X have a 1 in front of it.
Yes.
So it ain't nothing you could do with, wait a minute. Like you can't divide that 1x over that 2x on the end. Like if you add the 1 plus the 1 and
Oh,
the
okay.
4.
Because we are adding, no. If we were multiplying, yes.
Okay.
Adding, no, we're gonna leave this exactly as is.
Okay.
Good. Real
Sounds
good
good.
question. Real good question. Okay, so I want you all to try the next example. Ready, Freeman?
Yes.
Example 2. Let's try this one. So that's 5x to the 4th minus 45x to the 3rd minus 4x squared all over 9x.
Mm.
So let's look at the whiteboard. I'm not rushing anybody, but in case anybody is ready, I want to be ready too. Hey, Carol wrote that in bold ink. I like that.
I'm lost.
That looks fine. Keep going. I see what you have. Just reduce what you can, and those that you can't, leave them as fractions.
Oh, okay.
Brian, you still with us?
Yeah, I'm working it out on my paper right now.
Okay. I hope Bakelu is. Yes, Bakelu. Okay, never mind, Bakelu. I see you.
I'm coming.
I see you working here. Okay, that's good. Carol, are you doing anything, Carol?
I am. Sorry, I had to step away for a while. I'm back now. I'm trying to work it out now.
Thank you. We're gonna do this. Then we'll do one more example of dividing. Just make sure we're fine with that. Then we're gonna take our break.
So should something go right here, Professor?
I'm gonna say no.
Oh, okay.
I mean, if you want to put a 1 there, you can, but really just leave it as a integer. Hey, Brian, I like how you did that. And that is very nice. 100, Brian. Good job. Nice.
Professor,
Yes. You too,
can I go
Michaela.
further? Can I go further with this?
I would not have a X next to that 9.
Right here. Oh, wow.
I'm done, Professor.
And that looks very good, Michaela. Wait a minute. Yeah. Oh, and also, Stephanie, the first term has an issue with your exponent. That's good, Bakelu. I'm gonna give it 100%, Bakelu.
Thank
Freeman? Oh, yeah. Wait a minute. That's yeah.
I'm trying. I'm having trouble. I don't like this one. I'm having trouble
Yeah, that's
with
a
this one.
mess. Wait a minute.
I don't like this one. I can't get it.
Carol, I want to see something on your whiteboard, Carol. I'm sorry.
Let me try it. I just write
You
what I
too, Freeman. I need to see something on that whiteboard. Come on, Freeman. Okay, Taylor, keep going. Stephanie, you got something that in the first fraction has an issue with the first fraction.
I'm trying to figure out the issue.
Look at the X's.
Okay, wait a minute. I'm gonna get this. Okay.
And Freeman,
You told me it was I had it like this at first.
Yeah, well,
I tried, Professor. I don't know.
That's very close, Freeman. And
Okay.
Taylor, that is, hold on, Taylor. Okay. I'm looking for the denominator. Okay, Taylor, keep going. Almost finished.
Professor, I'm trying.
Hey, Carol, that's not your. Okay.
You
First
breaking
of
up,
all,
Professor. I can't hear you.
that is
Erase the whole thing.
No, not erasing the whole thing, but that's a great job, by the way, Taylor. 100.
Thank you.
So let's go with this because Freeman doesn't look very happy. Oh no, let me do it.
Hey, Professor,
Yes.
For this one right here,
Yes.
should it be without these?
Should it be without what?
Without these.
Without These.
without these X's.
Oh, okay. Oh, you know what? Let me go back to the whiteboard.
Can you explain it, Professor?
Yeah, please.
Okay, let's do that.
Please.
Okay. So we got to split these up.
Okay.
First fraction. Second. Last. Any questions here with that? No, Freeman?
No,
No. Mm-mm.
Okay.
I got that.
Can we reduce 5/9?
no.
No.
All right, that stays as is. What to do with these variables?
Subtract
The trick.
the
Okay,
exponent.
and what will it be?
It'd be 5x to the third.
Okay,
know.
x to the third in the numerator, right? And nothing else. That's it. Nothing else down there. You're subtracting the 4 from the 1 beginning to 3. So that's it.
Oh,
Mm-hmm.
Say that again, Professor.
I'm subtracting this exponent and this exponent.
Okay.
Subtracting those exponents gives me a 3. And
so
yes,
so why would we just leave the 9 by itself? Because that X is considered like a 1 and it divides itself out or something?
yes. Mm-hmm.
You subtract, okay. I gotta write my side note.
Minus sign here, minus sign here. Can we reduce these two?
Yes.
Mm-hmm.
That reduces to what?
5X.
5/9.
Well, I'm just looking at
Five
looking at the numbers. That's 5.
Okay.
5X2.
And that's gonna be
5X2.
x squared. Because again,
That's where I got confused at.
We're
I
gonna
left the 9
we're gonna subtract those exponents, get 2 here. Like we subtracted those exponents and got a 3 here. However, since 9 went to 45 evenly, we didn't need a denominator here.
there. Okay.
In this problem, 9 wouldn't go into 5. So we had to keep that fraction.
Right.
And minus sign. Can't reduce 4/9.
Mm-hmm.
What do we do about the letters?
Just
X.
So we would subtract those. 2 minus 1 gives you x to the first. That would be right here in the numerator. And good job, Taylor.
Thank you.
Solid. Excellent. Question on that?
I don't have a question, but I'm still confused. Like even the 4X over 2.
Wait, let me get back to the paper. The 4x over the previous problem.
Yes.
The 4x.
The 4X squared over 9X.
Okay, yes.
And it come out to be 4X over 9. So the X's, the 2, you want to take 2 from that 1 that's under the 9X?
Yes.
And is that how we got the 4X by itself up the top?
That is correct. Now, okay, look at it this way. As far as the numbers go, the 4/9, we kept the 4/9 exactly the same it was. The same it
Right.
was. All right. So with the x's, I just subtract the 2 from the 1. Subtract the 2 from 1, you're gonna get x to the first. And
Right.
You don't have to put the 1 there, but wherever the highest power is, that's where you're gonna put the answer.
Oh, wherever the highest power is, that's where the variable stay with that number.
Yes, yes, yes,
Okay.
yes. Did I keep that? Maybe not. But yes.
Can we do another one before the break or no? Because after the break, I think my pill's gonna kick in.
Okay, let's do another one right now. All right, let's do it right now before the break. Here it is.
I'm dead. Not the pills gonna kick in.
All right, here we go, people. You see it? You see it? I don't think everybody understands what happened yesterday, Steph. You want to give them the long story?
You guys, yesterday I was in a car accident coming home from work. So I'm on medication. However, it was my first day back to work. Now I'm back out of work.
Mm.
You said it was a
That's a
hit
good
and run
day.
too, right?
Hmm?
Did you say it was a hit and run?
Yeah, a hit and run. Hit
Yeah,
me from the back.
crazy.
Backed up and went up a one-way street.
Mm.
Wow.
So that's why she's
Medicated.
You should not in no pain. That's what they
Right.
want you.
Right.
Yeah, but I feel like a zombie. Valiums and oxycodone, you guys.
Oh, Jesus.
That'll
That's
do it. Ooh,
I
that'll put you
had-
right to sleep. You hear me?
I had surgery in January. Them oxys did not work for me. It just made me drowsy.
Mhm.
Oh, no, they put me
Some
straight.
people just make you sleepy.
Yeah, they didn't cure no
They just
damn
put you right to sleep and don't take away no pain.
Yeah.
You be still in
Right.
pain. You
Don't
don't
do
feel it
nothing.
because you sleep.
Yeah.
Sorry.
Unfortunately, Stephanie, I'm allergic to all that stuff. I can't take none of that stuff. I'd be in bad shape if I ever got in the car accident because they don't know what to give me. Tylenol ain't gonna do it. I'll be in
BC
bad
powder.
shape.
well, you know, Stephanie, I would not. I don't think I want to cover this new section if you're not there. So we'll after the break, we'll just review some of the homeworks on people's screens because the factoring is kind of important, the very beginning of it. So I don't want you to miss that.
Okay. And the homework I've done already. So.
All right. Any answers? Let's see on the whiteboard. Okay, that's Brian's old one. Bukalu's old one. Freeman's old one. Taylor's old one.
Professor, I'm coming. Come on now.
Just sharing what I see.
All right, I'm coming.
Awesome.
All right, I think I got this. What is going on with my internet?
Is that the answer right there, Professor?
Yeah, this is kind of, I don't know.
Is this the answer?
Mine's look a little.
This is the
funny.
question.
No, I'm saying what I got.
Oh, I'm sorry. Let me look.
You kind of
here. Okay, now you need to have a -1 at the end.
Right, I just saw that.
Oh my gosh.
What about my answer, Professor?
As Freeman.
I don't know.
You know what, Freeman? If we were like, if this was a test, for example.
Yeah.
And if that was worth 1 point, I would try to give you a half.
F. Okay. What is my exponents wrong or something?
Can you look at mine, Professor?
Yes, and a coefficient
I'm
issue.
wrong.
Was that who said that? Was that
Oh.
Oh, that was
No,
Carol.
that was Curl.
That was
I think I'm
Carol.
wrong. But can you check it for me?
Keep going, Carol. Keep going, Carol.
Okay.
And Bukelu, that's close.
Oh,
And waiting for Taylor. Taylor, I think you raised something. And that's
Lord.
better. That's better, Stephanie. Wait, man, let me make yours a little larger for me to see. If that middle term is 1, if that's a 2, then that's okay. I think that's a 2.
That's a 2.
All right.
Yes.
Yes. Oh, Bukelu, that's so close. Bukelu. Yeah, that's so close, man. Yeah, 70. That's real good. Uh-oh. Brian has me concerned a little bit. Oh, keep going, Taylor. First 2 looks good. Yeah, Bukelu, that's to be totally objective, Bukelu. If that was worth 1 point,
All right.
I guess I could give you half, a little over half, maybe like 7/10, maybe. I try to make that 7/10, Bukelu. Oh, Freeman. Okay. All right, that's close. All right, let's do this. Okay, very nice, very close. So we know the procedure. Yes, we're going to break
Yeah.
these into 3 smaller fractions. Need you to watch this, Bukelu.
Oh, wait a minute. One.
So the 8s, 8 divided by 8, that's 1, right?
yeah.
All right, so you don't have to put the 1 there, but understand 8 divided by 8 is the 1. And then what's next?
X square.
X squared, all right. Okay. Plus sign. The 4/8, we make 1/2, right?
Yeah.
What's next?
Oh, okay.
X.
Oh, okay.
X where?
At the top.
Okay, fine.
And then -1.
And then -1.
Oh.
8 divided by 8
okay.
is 1. The x's cancel out for Kelly.
Okay.
8 divided by 8
Okay.
gives you 1. And
Yeah, okay.
you don't really need the 1 here. You don't really need the 1 here, actually. Although you could put it here. So this is a nice answer. Now this is what Kelly wrote something like this. He wrote x over 2 plus 1/2 x. That's okay. He put a -1 there. So either one of those is nice.
Mm-hmm.
Or I guess, or here's the other way. You could say x squared plus x over 2 minus 1. There's a third way right there. All correct. So it's break time.